Hello, I'm Hyuk-Jun Kwon, one of the first authors of this paper. We are glad to introduce our research in CVPR. Point cloud semantic segmentation aims to identify the class of each point. For this, most of the modern methods are based on deep learning, especially using fully supervised approaches. Here, a model is trained by minimizing the loss between prediction and ground truth in a point-wise manner. However, obtaining point-wise GT is usually extremely expensive and labor-intensive. As a remedy, weakly supervised approaches have been studied, using only the weak labels which have less information yet are cost-effective. Especially, using partial annotations has shown promising results. However, limited information inevitably bounds the performance of the model. Against this background, in our paper, we explore what can be a new source of knowledge. Our direction is using the recently published foundation model for segmentation, which named SAM. SAM can perform promptable segmentation by requesting input prompts to indicate what to segment from an image. Thanks to its substantial performance and generalizability, SAM has been widely integrated into various works in the imagery domains. However, our goal is weakly supervised point cloud semantic segmentation on the 3D domain, unlike the SAM on the 2D domain. To handle this gap, we use projection as a bridge between the 2D and 3D domains. As a pilot study, we introduced the PP2S module. In this approach, we use projection to obtain 2D points from partial labels and use the points as input prompts for SAM. Then, the predicted 2D masks are back-projected to the 3D domain again, providing 3D masks. The 3D masks can serve as pseudo-GT for the training point cloud model. As shown in the upper right table, the use of PP2S greatly improves the performance. However, we also observed several limitations in PP2S originated from the noise pose or SAM ambiguity. These are mainly due to the fixation of enhanced weak labels after using the PP2S module. As a remedy, we aim to refine the labels in an online manner. Specifically, we use PP2S module as an artificial oracle within the context of active learning. As we done in the pilot study, PP2S gets point prompts and returns 3D masks corresponding to those prompts. Unlike the human oracle, PP2S can provide mask that corresponds to input query but cannot annotate the query's class. Therefore, we query the point confidently predicted by the model, which can be self-annotated. We elaborate our approach as a framework named Reason Exploration via Artificial Labeling. In the real framework, we first identified reliable points as input query for PP2S module. However, the most confident points are most fixed during training. This hinders the exploration of query from the initially known reasons, resulting in still limited labels. Then, how can we promote the query sampling to explore the unseen reasons? As a remedy, we devise our framework to select query only on the unseen reasons using the previous labels. The proposed query sampling strategy helps real framework to gradually explore the unseen reasons, leading to the better labels as training proceeds. This is why we name our framework as Reason Exploration via Artificial Labeling. Using the result of the artificial oracle, we update the previous labels yt-1 into the updated labels yt. The updated labels yt are subsequently enhanced to yt+1 in the next iteration, and so on. We verify the effectiveness of our approach on a 3DIS dataset, comparing it with its OTA methods. Notably, PP2S itself brings impressive gain integrating the SAM for the 3D domain. And real framework even further effectively exploits the PP2S in an active manner. Consequently, the proposed method achieves new state-of-the-art, surpassing the existing studies. The visual comparisons further confirm that the proposed approach achieves substantial results. The colored boxes highlight that REAR can reject semantic confusion and present precise segmentation results. For intuitive understanding, we also provide the samples of progressively enhancing labels. As training proceeds, artificial oracle effectively enhances the quality of labels. Specifically, the initially unlabeled reasons are gradually explored by real framework and correctly labeled in an online manner,